Hi, and in this video, we're going to implement our first orchestration system with use of large language models with our own tools with function calling technique. We're going to use the LiteLLM as the framework, which, and if you're not being familiar before, represents the gateway for the developer towards the various providers of the large language models from the third-party services through the concept of so-called the endpoints. So if we can scroll down, we can see that among the list of supported providers, chat completion is one of the common endpoints that we are going to use, and it is supported among the various set of the providers. So let's navigate to the documentation. It has a really big community, and they have broad support for the related documentation that describes providers. We take a look on the endpoint of the chat completion. We have the set of the input parameters, and also it gives us a documentation of what we attempt to use and how we will structure this video. So we're going to follow up the completion endpoint. It's the unified method where you can supply the model, messages, and the rest of the parameters that's going to be used to customize it for your needs and later purposes. We're interested in the messages, and also let's take a look how this parameter is organized. So properties of messages. What we're going to see in this video, so each individual message must form and yields off the following parameters. So it describes the role, content, name, and two remaining, and the most important one will be the function call. Is the name and arguments of the function that should be called as generated by the model, and identifier, it just represents the reference to the corresponding handler. In order to start the actual tutorial, we're gonna follow the documentation page which describes the function call principle. So I don't know from this link, it's just called function calling. It provides an example for the ChatGPT 3.5 turbo, but we're gonna quickly proceed with the corresponding example that they provide us here with the full code, and this is going to be our starting template to walk through for the reproduction purposes. So we're going to tackle the function calling principles, and after that switch to our first example and basically trying to see how it results in our first agentic behavior. I'm particularly using the LiteLLM version of 1.88.1 and its API to accessing the ChatGPT models. This is the quick example that demonstrates a single tool, get current weather, that outputs weather conditions for the list of the predefined countries. So that's how we declare in the tool. And then we initiate the main messages. What's the weather like in Moscow today? Received from the user. We use LiteLLM and the completion function, for which we're passing the ChatGPT 5.4 model. So this particular model supports function calling. So long story short is that such models that support function calling means that they were trained on a specific data set where they know whether there is a need to use the extra tools or not based on the list of these submitted tools. So this is something you can check whether this model supports or not. The LiteLLM has the related call supports function calling. Because if not, so then the other option is you have to do the orchestration by manually providing the tools. But at this point, if so, then we can pass the ready tools here and activate the automated choice if they are in need to use. So once the query is submitted, so what we're going to do is checking that whether there's a need to calling the any tools. Again, it's because the function calling is automatically supported by model. And within the rest of this content, and what I wanted to show with this example is how to form the list of messages so that you will have a natural output based on the function calling. For that, I need to again launch this example. That would demonstrate the list of the messages. So as you can see in the end, we'll see by querying the weather in Moscow, we're seeing the Moscow today is 15 degrees. It's because of the definite setting tool. So what I want to put in attention is the information list of messages. Here, the first message is what we saw, was submitted from the user, while two remaining one is how we form statements concerning that we use a particular tool and provide also the output for the registering the output for the particular tool. So for each particular call, all we're going to do is we append the first message, which describes the role of assistant and acknowledge the fact that we call the particular function by mentioning its name, arguments, and registering its ID. And then the following up messages must be a response from the tool. In this case, we manually launch a register function based on its name, which has, again, this one, the current weather, and to be in the end. And we submit the result in the form of content, as we can see here, the location and temperature. And then, so how we get a nice response, we proceed with the, again, calling the completion based on a set of messages. So that's the model returns the output based on the history. All right, at this point, what I'm going to show you is that with the example we just saw, I renamed it as the weather.py when we're using only one tool with weather. We have the concept that we can use to implement our very simple orchestration mechanism with the LLM. So everything that comes after the check of the existence of the tool calls, we can actually put into the loop, and I create a file for this, loop.py, where we have the corresponding method, which is called orchestration loop. So the mechanism is pretty straightforward and follows concept 4. So first, and once we have messages, submitting tools and handlers for them. Handlers is a reference to methods. So what we're going to do is we initially query the LLM in order to assess what kind of tools we need in order to reply. If so, in need, then we falling into this loop. And as we saw before, all we're going to do is iteratively call every single tool, compose the related messages, and then ask for whether we need to repeat the further actions or not. And if not, then return messages. Where the way we call in the tool is just we return these two messages. The first one initiating the call of the function, and the second one is we returning the result of the corresponding function. The example to can demonstrate this, we can actually extend and add more tools that we want to call. So let's say now we have current weather that we want to query, is what we saw before, and we extend it with the population of the location. So here we register 2 of these tools. We compose handlers, and finally, within this example, all we're going to do is we ask the user to enter the query. It's when you imitate our chatbot, and once the query is submitted, we launch our orchestration loop. So this is, I'm going to demonstrate how it works. So we're going to enter the query. At this point, Moscow is not registered. So it says I can fetch the current temperature right now. But we know that the Tokyo is registered. So how about Tokyo? And as you can see, it will give us the weather information. So we can also proceed with the population. Tokyo, please. And gives us the corresponding response. Okay, so at this point, it gives you a principle how you can tackle and deploy your tools for the orchestration purposes using the LLMs. And here's the small follow-up that we actually can simplify our orchestration loop. If you remember previously, we have here the initial call for the query, followed by the checking for tools needs to be called. We can remove this instruction and enter in the loop straight away by passing the placeholder, so which allows us to check first whether there's a need to call in tool or not, which is in the initial call, we're skipping this part, and then proceed normally following up query submission, which results staying in this while loop again. And another small change that has been applied is concerning the approach and where we're sending the arguments. Previously, we're sending as a string, but obviously it's not possible when it comes to multiple parameters, so we have to pass it as a key value arguments. And for those who noticed that our implementation is not yet complete because we just are waiting for the whole completion. So in order to support the streaming as one of the common technique that we used to see in previous videos and in general how the agent behaves, it's again a recall to the API for the completion provided by LiteLLM. We have the parameters streaming, as you can see. So you can technically set it up. Let's take a look. So you can activate this. It says that if set true, it sends partial message deltas. tweaking only this flag would allow you to switch to the streaming behavior. You can also have certain options in here, which it could be activated upon setting the flag to the true. Apparently, it's quite useful for the token usage and statistics, so you can also gather this information and form the related statistic on the side while completing the messages.